Welcome to the video lecture series of Grade 10 Physics. Today we will discuss the lesson electricity. The topic is Joule's law of heating. We know that a battery or a cell is a source of electrical energy. So when we connect the battery to this entire circuit, it provides electrical energy so that the current is maintaining through the entire circuit. Which means to maintain the electric current, the source has to keep expending its energy. So where does this energy go? A part of the source of energy in maintaining the current may be consumed into useful work. Which means if you are connected a fan or any other devices in the electric circuit, a part of the energy is used to rotate the blades of the electric fan. What happens to the rest of the energy? The rest of the energy may be expended in heat to raise the temperature of the device. But in this circuit, we have not connected any other devices. We have only a resistor R we have connected over here. Okay. So in this electrical circuit, only we have a resistance. So where does the energy go in this case? Okay. So one part of the energy is used for maintaining the electric current in the circuit. On the other hand, the source of energy continuously gets dissipated or radiated or used entirely in the form of heat. Which means if you have not connected any other devices in an electrical circuit, a part of the energy is used to maintain the electric current and the other part of the energy is used in the form of heat. So this is known as the heating effect of electric current. So this effect is utilized in devices such as electric heater, electric iron, etc. Now, for a steady current in the circuit, the amount of heat produced, H, we use a symbol H to represent heat. So the amount of heat produced in the circuit is H is equal to V into I into T. Means potential difference into current into time. When applying Ohm's law in this equation, so as per Ohm's law, V is equal to I into R. So if you substitute V with IR, so the equation becomes H is equal to IR into I into T. Now I is coming two times, so you can write I square into R into T. So this is known as Joule's law of heating. H is equal to, H means the heat generated in the circuit is equal to I square RT, which means the heat produced in a resistor is directly proportional to the square of current for a given resistance. H is directly proportional to the current, square of the current for a given resistance, then it is directly proportional to the resistance for a given current, which means R, and it is directly proportional to the time for which the current flows through the resistor, which means H is equal to I square RT, and this is known as Joule's law of heating. Now we can solve one or two numericals based on Joule's law of heating. Look at this question. Compute the heat generated while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volts. So compute the heat generated. So we need to calculate the heat generated. H we have to calculate while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volts. So charge is given here. What is the charge given? 96,000 coulomb. So Q is equal to Q is used to represent the charge, you already know. So Q is equal to 96,000 coulombs. And how much time? T. T is equal to 1 hour, which means 60 into 60 seconds. That is 3600 seconds. And the V also given. V is the potential difference. That is 50 volts. So V is equal to 50 volts. We already know the equation H is equal to I square RT, but here there is no resistance given. So we can use another equation, that is H is equal to V into I into T. But as per this equation we need current. But current is not given in the question. So we have to calculate current. Current I is equal to Q by T. What is Q? Q is equal to 96,000 coulomb divided by time. Time is equal to 3600 seconds. So on further calculation, you will get it as 160 divided by 6, or we can write it as 80 by 3 ampere. Now we can calculate H. H is equal to V into I into T. So V is 50 volt into I is equal to 80 by 3 and T is equal to 3600 seconds. So with on further calculation, we will get 80 into 50, that is 4000 into 1200, which means 48, then 5 zeros. So this much joule heat we are expressing in terms of joule. Okay, so 48 into 5 zeros, which means this is this much amount of joule is produced. This much amount of heat energy is produced while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volt. Okay, 48 lakh joules of energy is generated, but this we can further simplify by converting into kilojoules. So 48 lakh divided by 1000, so you can convert this into kilojoules. So you will get 4800 kilojoules of energy. Fine. Now we can solve one more problem related to this Joule's law of heating. A second problem is given over here. An electric heater of resistance 8 ohms draws 15 amperes from the circuit valves in 2 hours. Calculate the rate at which heat is developed in this heater. So an electric heater, the device is electric heater. Okay, its resistance is given 8 ohms and it draws 15 amperes. This is the current from the circuit valves in 2 hours. So we need to calculate the rate at which heat is developed. Okay, so resistance is given. So R is equal to 8 ohms and it draws 15 amperes, which means that is a current. I is equal to 15 amperes. Then what is the time? Time given is 2 hours. So T is equal to 2 hours, which means 2 into 60 into 60. So you need to convert it into seconds. It will become 70 to 100 seconds. 7,200 seconds. Now, so here you have to calculate the rate at which heat is developed. So heat we should calculate by the time we should convert it into rate. Rate you already know. How do we calculate rate? Rate is the heat developed per time. So here time is 2 hours. So you already know the equation for heat to calculate. H is equal to I square RT. This is the expression for heat energy. But by the time we need to calculate the rate at which heat is developed. Heat is developed. So this expression I square RT you have to divide with the time given. Okay, so T, I'm just writing it in small letters. T. I square RT divided by T. So you will get the rate at which the heat is developed. So I square RT, I is 15 ampere. So 15 square. 15 into 15 into resistance R is equal to 8 into time. Time is 7,200 second divided by T. T is again 7,200 second. So when you cancels T on both sides, you will get 15 into 15 into 8. So 15 into 15 is 225 into 8. So which is equal to 1800 joules per second. So this heater is, the rate at which heat is developed is 1800 joules per second. Thank you, children.